Great. So now that we understood how to like unwrap on mouse down that we were like placing on all of our objects, and we were able to now talk about the update loop and user input and casting rays from the camera and checking where the user is, and then shooting rays out and checking if we hit something. We can actually talk about some of our major ways, alternative ways that we can check it, like shooting through the camera into the world and end up creating stuff. So what I was just describing, so now that we're kind of moving off the unit click, I'm going to either turn off unit click or remove the component. Either way, I don't want this functionality to be running in my game anymore. So just so you know, if you want to remove a component or like disable it, one way you can do is to remove component and it's gone. And the other way is you could just disable it like that. Now it's disabled, but still there. Either way, we have no unit clicks that are doing anything of substance. They're disabled. And I'm going to create a new object. And I end up just calling it the click detector in this class. Just it's detecting mouse clicks. All right. You can call it whatever you want, but I'm going to drag. I think it was screen point to ray. So I'm going to drag this script on. And just notice there's a lot of stuff that's commented out. Just ignore the commented out stuff, all right? And I'll cover what this layer mask is later. But for now, just notice we have an update loop. And now we're going to check if there's user input. These are a little bit different. The other one was saying, hey, get key down, and you could check like almost anything. I'm going to use a little bit of simpler method, get mouse button and get mouse button down. So this only relates to mouse buttons, and we don't have to use an enumeration. We just have to pass in an integer. You just have to know that 0 means left clicked, 1 means right click, and 2 means middle click. So what this means is go to the input class, get mouse button down returns true only when you first press the mouse button. And which mouse button are we talking about? Left mouse button. So this is like only when there's a left click will this be true. And this is the OR operator. And this is saying OR get mouse button returns true when you're holding it down. So this is like a drag. And which drag are we talking about? The right drag. So this is true if we're left clicking or right dragging. And just so you know that that's OR and this is AND. This means either this could be true, or I'm sorry, this needs to be true and that needs to be true. So you need to be like holding down the right mouse button, and only when you first click left will this become true, which is like user input that nobody does. So in this situation, we want an OR, but sometimes up to you. Sometimes you want ORs or ANDs, and you can get like a compounded logic statement. Now the next thing that we do is we're creating a vector3 variable or object called click position. And a vector3 is basically just like a really nice object that wraps up the idea of 3 floats for usually 3D positions, but it can also deal with direction or rotation or scaling. In this case, I'm just saying vector3, call this class, go into it, get its member property called 1, which is just a shorthand for writing vector3 111. And I just negate it. Putting a negative in front of it just makes a negative on each one. And the reason I do that later on, you'll see it's like you'll never get that. Like no matter where the mouse position is on the screen space, you'll never get -1, because that's off screen space. But just so you know, you can also say like, okay, create a new vector3 of like -1, -1, -1. saying create a new object of type vector3. Like this is just as valid as this. It's just since people create these type of vector3s a lot, you can just create this like little quick static constructor. But it's like saying this. So you've seen this before. Create array object. Go get me the main camera. Go find me where the user's mouse is on the screen. Go shoot array out. Make me my raycast hit object. And this one's more complicated, so I'm going to turn that off using that multi-line comment and turn this one on. And so we're going to attempt a raycast with this ray we just created. And if it's true, we're going to do this. We're going to get the impact point of, we got that hit structure that got written and is coming back out. We're going to grab the hit point, which is basically like the 3D position of where our raycast hit something. And we're going to record that to our click position. We create it up here. I'm just like constantly writing new values into it instead of creating a variable every time. And then this is something new. We're going to use the GameObject class, and we're going to call the createPrimitive method, and then we have to say which primitive are we creating. And this is exactly like going up here and going to here and just clicking one of these. It's just we do it by code. Behind the scenes, this is just calling the same code. So if I get rid of this, this is an enum as well. It's a different enum called primitive type, and this is the list that is available to us. The stars just mean these are the popular ones. So here's the list. And you can select what you want. I'm going to select sphere. And so here's another enum. Really, you should see the benefits of using it. I had a defined list I could pick from. Tell me create a primitive of this type. You have to create a reference object. You have to say, like, well, once you create it, that's great, but like, what is it? Where you need to create a reference to it. So we create a variable type game object and point it toward that, so we remember it, and then we can use it later. Which, how are we going to use it? And saying, hey, I just created this game object, which has everything built to make it look like a sphere. So go into its transform component, because I know it's going to have it. Go get me its position and set it to this click position. So the end result with this is that I need something to be a collider to click on to create this type of interaction, have the raycast be true. And notice nothing's happening. If you look right at the bottom here, there's a print statement right here. That's what's printing out right now. This was doing it last class. I had to like reset it. Should generate right on those spheres. But I wanted to show you generate on that sphere before. But what I ultimately do is I'm going to create a plane. I'm just going to rotate it toward the camera, which ends up being -90, just the way that they build a plane. I'm just going to move it back a little bit. And in the game view, you see like there's a little plane here. Oh, this is wild. So my last class, I do debug.log, just say like hi. I just want to print, like, if I get in here and everything is true, I just want to print hi. Okay. So for some reason the script didn't like it. It's weird. It's the same code, but the fact that it needs to be like rebuilt and put into Unity or whatever. But anyway, the point is that notice that I'm clicking on this plane, which has a collider. It's called the background. And it has a collider. So the physics system is returning true. You're clicking on it. But if I click over here, I'm not creating anything, but I am getting these debug printouts because no matter what, there's always this debug printout down here. But now this is what you can see. I'm generating spheres on top of spheres because they have colliders too. So, and now if I hold down the right click, they like come shooting out right at you. Right click is going to be a drag true. So left click is like creating one at a time, and right click is like creating multiple of them. But you see, they kind of like start they all have colliders. The distance gets shorter and shorter, and it starts coming towards us. So that's one thing we can look at fixing. But before I do, let me get rid of this debug statement. Don't need that anymore. Let's move to this more complicated one. Okay, so it's the same method call, but we have more parameters. So if I hover over here, notice it's saying plus 15 overloads. So it means this raycast method can accept like up to 16 different combinations of input parameters, and it changes its behavior. Basically, they wrote out a method definition for each raycast 16 times that like accepts different types of inputs, and it does different types of behavior based on which acceptable input you give to it. So here we still have the ray, we still have that hit structure that's coming out, but we also can designate how far out are we shooting the ray. Usually it goes off to like infinity, and that can be expensive. So you have like from the camera all the way off to infinity, which we don't always want that. This just says only make the ray go out 100 meters. So in the game engine, we work in units of meters. So it says just limit the ray length to 100 meters. And this says what type of mask, what type of layer do you want to filter your results on? So now we've talked about names, we have tags we talked about, and layers. And layers is usually for physics. So think of it as like a filtering way. Like sometimes you have a lot of stuff out there in the world, and you don't want all these collider hit impacts to return back to you. So I'm going to call this my my background, this plane, and I'm going to put it on a layer. Actually, last class I created a layer, but these were like the default layers that are given to you. I just created a new one. I call it like hit target, whatever. But I'm just going to say, hey, put on layer hit target. So, and then notice that these two spheres in front of us are here, and they're on a default layer. So if I go to ClickDetector and say click mask, okay, only give me positive results for stuff that's on the hit target layer. So that's what this public, give me a public variable of type layer mask, and just call it click mask. It's public, I can edit it in the inspector. And this is saying now, okay, only stuff that's on click mask is going to give us any good results. So notice I'm kind of clicking right through these spheres. And notice now these spheres aren't like flying at me because I'm not using them as acceptable colliders. I'm only allowed to paint on the plane. And no, I can't paint off the plane, and these spheres aren't like flying at me. All right, so that's a layer, like a filtering mechanism. Okay, I'm going to turn this off, and plane raycast is next, and I can turn off my plane. I didn't delete it. I just kind of deactivated it. I turned it off. I don't want to use it anymore. I don't want to see it. And let's look at this plane raycast. So very similar. We have our update loop. Same type of input filtering. Are we left clicking or right dragging. We have a vector3 variable that we can write to, but now we're creating a plane. So we didn't call this like create primitive thing, which creates an object for us. And we use this new keyword. So plane is a class, and whenever we say like new of this type of class, it creates an object. And it's saying like create a new object of type plane that has these input parameters. So I'm not going to get into this because it's like how to orient the plane. Notice I had to like rotate that plane like 90 degrees toward the camera. That kind of does it. It's saying where do you want the plane to point, and forward is just a z direction, but you don't need to understand this. This is basically creating a plane game object, but it's more like there's no visuals. I don't set the renderer. It's invisible. It's just like this is a plane object that's got a collider on it. So it's just like for collision, and it's not really for visualization. And it's like built procedurally, and we're just going to store a reference to it. So we have a variable of type plane called lowercase plane. And we're going to create array, the same situation. Shoot array out from wherever the mouse position is, create array into our world. But notice we're ray casting from this like procedural plane, and we have to pass in the ray and pass in the distance to the plane. And if we get and our results are once this is processed is we can create a point. So from the ray, which is this object here, call getPoint, and it returns a point this far out. So imagine array is like this vector, and we can say, hey, a certain distance out along it, just tell me that point in 3D space. And that's what we're getting here. And then we do the same thing. We're just creating our primitive, but placing it with this click position. So it's a little bit different. We're using this like plane object, which has some kind of physics properties to it. The benefit of it is we don't need to like create a plane, like a background plane. We don't need to look at it. And we only generate stuff right on it. Like there's no other color, like we're not painting on the other spheres. We're just like, now we're just able to paint everywhere basically too. So it's like giving us a canvas, like a painting area. So that was plain raycast. And then the really important one that we're going to be using for the remainder of this class is what's called screen to world point. So we don't even need to really deal with colliders anymore. This method's really useful. It's saying, hey, wherever the mouse position is, wherever the user has the mouse position over the screen space, just go a certain distance out and just tell me what that position is in 3D space. So up here, I have this float variable called distance, and it's set to 10 meters. I'm going to come back up here in a little bit, but just note that here we're still going to the main camera, but we're calling a different method called screen to world point. We're passing in the mouse position, and then we're adding to it basically a z number. We're passing in this distance. So what we see here is if I hover over mouse position, it's a vector 3. But in reality, we're only writing to x and y. We're only writing to left, right, up, and down because we're in screen space. So it's a vector 3, x, y, z. Z is always going to be 0. But in addition to adding integers and floats and strings called string concatenation, we can also add together other objects if they have helper methods that allow you to use these operators. So this is called vector addition. We're taking a vector 3 plus a vector 3. And the way that vector addition works is you just add up the x's, you add up the y's, you add up the z's, and you get a new vector. So in this case, mouse position x and y will always have some data. Z will always be 0. So we're adding zeros to x and y. We're not changing those. But we are adding a distance value to z. And we're creating a new vector3, and we're passing in the parameters each time. This distance just happens to be 10. So we need to add a vector3 to a vector3. So it's why we have the mouse position plus this new vector3. This distance right now is just 10 meters out from the camera. But in any case, we add all this up. We do our vector addition, and we pass that in. And this figures out where in the actual 3D world, based on wherever the camera is located and the camera is looking, where this location is at. And then we have that. We store that as our click position, which is a vector3. And then we go through the same thing. We create a primitive, and we store a reference for it, and then we go into its transform, into its position, and set its position. I do some more stuff here. This is where we start getting into like randomizing the scale and randomizing the color and destroying it after 3 seconds. But I'm going to start up on this next week. So when I click play and I paint, you'll see like different colors and different scales. But that's not what's really important to see here. What's important to see here is that, oh wait, let me turn off that distance change. Hold on a second. What's important to see here is that we're painting 10 meters out from the camera. So it's kind of like that plane raycast, but now we don't even need to deal with creating up that plane. We don't even need to deal with raycasts. We're just saying, look, the camera's looking out into the world. The user has the mouse somewhere in the screen. Just shoot out 10 meters and start creating stuff for me. So we're actually starting the painting flow from our user flow diagrams. So one thing to note here is, see, this distance is exposed. So like I can increase it, it's farther away. I can decrease it and it's closer to the camera. In distance change, I'm just going to talk about briefly. If you just add a little bit to it, notice how it's going away each step. And I can make it like negative, and I can bring it back. It flies way too fast, but see, I can bring it forward and backward. So I have this idea of distance and distance change. So one thing to note is I did say, like, when you make stuff public, it gets exposed into the inspector, which is super useful, but sometimes you don't want to make everything public and risk the chance of someone else messing with the number. So what you can do is make something private and just say serialized field. And when you see these little square brackets, it's like little commands going into the compiler. In this case, it's saying make it a serialized field, make it serialized, make it exposed into the inspector. So that's just what that means. But now I can mess around with the distance as I care to. And distance change as well. It's a serialized field, even though it's private. So what's this distance change doing? All it's doing is if it's any amount other than 0, we just keep adding it to distance every time we're drawing. So what it should be is like a small, like you saw I was just doing like 0.01 or something, because it just changes this number, but it's happening a lot. So what I could say is like, if I could say what's my like a distance max, I'll say is like another 10. No, because if it goes to 0, it's going to sit right on your face. Let's just say like 6 units. So 16 to 4. So like if distance is like greater than let me just say if a max, let me make it a little simpler for myself. I'll say distance min. Let's say if it's 20 units away from the camera, you better start heading back. And if you're like 5 units to the camera, which is getting pretty close, you better start getting away. So if distance starts getting greater than distance max, then we can add our little change on to, we can subtract. Let me see. No, if it's greater than min. If it's ever greater than 5 units, you can keep adding to it. Or if distance is I've done this before. You have to check which direction it's been going. So it's I wanted just a little simple if statement and have it ping pong back and forth. But this is getting a little bit. I'll just say direction. Private. I'll try to wrap this up quickly. I just wanted like something fun, but this turned into like I'm just saying is going away, and by default I'll say it's true. So if we're going away, if we're like moving away from us, and the distance starts getting greater than max, if we're moving away and we start getting too far away, then we want is going away to be false, and we're gonna take we're gonna take distance off. Okay. Else if we're not going away, meaning we're moving towards if we're moving towards the person, towards the camera, and distance becomes less than distance min, it's getting too close, then we want to start moving back away again. And we can start adding, I don't know, we'll see. See if this works. So I was kind of messing within the inspector, and I kind of want to just see it. I can just show you that once you're tweaking it in the inspector. Oop, I got an error. Random. I didn't want to mess with this stuff. That's for next class. I just wanted to show you. Do I have this? Why do I have system? All of a sudden it's maybe because I referenced that bullet incorrectly. I called it capital B. And then it would start referencing the system library. Okay. So I just want to put, it's going to be going away from us. So I'm just going to put like a small amount and see if I can get a ping ponging going. No. Okay. If we're ever getting too far away, let me try this real quick. If we're ever getting too far away, we're just going to flip distance change. Yeah. So to start with, we're going to move away from the camera. So distance equals whatever distance change is just add that onto it. But if we get too far away, just multiply this by -1. Just flip its direction. All right, let me try that. Maybe I don't need this. If distance gets too far, flip it. If distance gets too close, flip it as well. And no matter what happens, just add that little distance change to distance. So I can see the distance value is 18, 20, and now it's coming towards us, 15, 12. It's just slow. I should probably speed up. But yeah, he's getting bigger. 8, 7, 6, 5. Cool. Let me just speed up by like a factor of 10, and then that's it. There you go. Cool. All right, so I'll cover, that's it for class, and I'll start up down here, and then we have, more stuff to cover. But we're creating stuff, we're painting stuff. And so we have like the first core part of our app done.